Hello, children. This is Professor Homer Cocktail. Oh, yes. I did attend one of the Claremont colleges, and I did receive a diploma, Bachelor of Arts, and I did get a passing grade in calculus when I was there. This is an aid right here. This is one of the aids that helped me. Can't find the other part. You'll notice it's in old-fashioned VHS form. And I do have an old-fashioned player here with one of the old kind of TVs, and I even have the device to convert it. And those were helpful. Those were very helpful. Those two VHS tapes. I don't know where the other one is. That was actually part 2 I showed you. And I also took the liberty of checking around what's online. So, right in here, on the good old trusty tablet. These new tablets are electronic, of course, unlike old clay tablets. We have calculus lessons that you guys can find if you have such device. You see? And there you go right there. See? Video calculus. And, there's other programs. And I didn't intend to let a year pass. Didn't mean to let a year pass from the last time I was posting. Except, I'll give you an analogy. Right in here on a little trusty phone. See, right in here, before I graduated, I began to do my little calculus thing. I was going to talk about the movie Stand and Deliver, which talks about calculus. You know, one of them. What's calculus? Anyhow, and what I decided is that it's not something that ought to necessarily be taught initially from a pure mathematical standpoint. 2 plus 2 is 4. Definite answer as far as the mathematics. Philosophy. If you don't understand the philosophy behind calculus, then you're not going to understand calculus. So that's what this video is going to be a little more about. When I was taking calculus, actually when I was taking pre-calculus in the 90s, at a community college, there was a lot of writing out of equations, and as technology sped up, by the time I got to the Claremont colleges, we weren't expected to write out stuff that could easily be programmed into a computer. No different than I didn't learn how to do square roots, but the generation before me and the generation before that had to manually do square roots. By the time I was born, the pocket calculator was enough, and why longhand figure out something that you could figure out in a couple of seconds. The application of calculus is still valid, and I have some paper that I snuck somewhere right in here. Okay, and we'll show some examples. To get the gist of this. And we're going to need a marker from right over there. And we're going to have to resituate the good old camera so that it is filming some examples. Okay. Like we said earlier, 2 plus 2 is 4 in a pure mathematical way. Okay. Go ahead and illustrate some of this. right here. 2 plus 2 equals 4. You get 2 dots there. You get 2 dots there. Right, 2 here, 2 there. And 1, 2, 3, 4. The obvious thing is what? 1, 2, 3, 4, right? That is 4 dots. Now in calculus, what we're going to start doing, go to the trig video and you'll see an x and y axis. Okay? You have 3 spaces here, 3 spaces there. In old math, what you got is okay, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 equals 9. Okay, that's easy enough. Now, by the time that we get into calculus, what we're doing is changing that thing to that thing, f of x. So that the function, f stands for function, the function of x is equal to 9 as far as area for that particular problem. Now we could start going longhand instead of y, right? Y equaling whatever it is, we start writing f of x equals, whatever that is. And sometimes we're presented in life complicated things. Like, what if it's not a straight thing? What if it's curving? Well, what you want to figure out, one thing you can do is continue to figure out things that are not round, right? If this is 3 high and 2 wide, that's 6, right? 3 times 2 is 6. And if this is 5 by 2, that's 10. This one's 10. Let's see, that one's 9 high. So, and it's 2 wide. That one's all of a sudden, oh, this is 4, not, that's 8. This one's 3 high by 2. That one's 6. Then you could add the rectangles, you see. And what calculus will do is it'll make those increments smaller, see? Smaller, so you have a more accurate sense of how much surface area. To the point that your answer is a very close approximation to what would literally be true. So if you want to know calculus, what you have to know is that there are no perfect answers in a lot of ways, as there is in other math, but rather approximations that are so close that it really doesn't matter how close you're off. And one word that you'll come across is epsilon. Okay. Let's go ahead and do another model right here. All right. Okay. Let's go back down here. Okay. Where there's an invisible line there. You have a certain equation that approaches that visible line, but it never touches it. Okay? And the distance here and here and here is all significant and measurable. But as this thing approaches something called infinity, the distance is so small that it really doesn't matter. Okay? I'll give you another example. Suppose you have a bag of oranges, Okay, a 2-pound bag of oranges. And you have a 2-pound bag of apples. Then you come home and you find out, holy crap, I only have 3.9 pounds of fruit. Or maybe 4.1, maybe you have too much. Because in life we accept close approximations, okay? We don't always go about life telling someone that you said you were going to give me 2 pounds of oranges, and I went home and measured. It was 1.999543. That just doesn't happen. So calculus, you gotta understand, more as a philosophy than anything else when you start off. And then I'll give you a final example too about adult kind of problems here. Whoops, I'm trying to lick my thing and carry on away there. Okay, let's suppose you have an amphitheater. Okay, you have an amphitheater and you have so much building material. Okay, and you gotta have seats, right? And you gotta have acoustics, okay? You have so much money, you have so much, building material, etc. Now, just like before, where there's a perfect answer for 2 by 2, okay, we got 2 blocks wide, 2 blocks high, and that's 4 square feet, okay, that's feet, and this is feet squared, or whatever, however that goes. What you're going to get is a complicated world where you can figure out the limits to your seating capacity, but then you can compromise your acoustics, okay? Meaning that the quality of the sounds in an amphitheater. And at some point, once you get past some of the basic arithmetic in life, these things go on in economics and government and some other things, is you just have to accept that the perfect answer quite often is what your opinion is. And there's better ways to do things than other ways. But there's some places renowned for their incredible ceilings. Okay, and ceilings are going to help you with the opera and natural situations where you don't have electric amplifiers like they do, where you go to Irvine Meadows, it's now called something else, and you can listen to people play rock and roll, but they're using electronics to compensate for what they don't have in some of the classic places in Europe, whatnot, with stone. Okay, in like a cathedrals, where before the electronics, you had to have a strong voice and you relied on sound echoing off the walls and the ceilings, etc. So, what's the perfect amphitheater? Well, a lot of that depends on how many people do you want there. Do you want 10,000 people, like at Irvine Meadows? Do you want 100,000 people, like at a Pasadena Rose Bowl rock and roll concert? Without electronics, that's horrible. That's horrible for acoustics and sounds, but it's great for seating. So I can go ahead and close this calculus video and submit it. Knock 'em dead. Learn calculus, knock 'em dead.